Good morning, everyone. I'm Samudra. Today, I'll be presenting a part of my PhD project, which is about the reinforcement learning for evolutionary game analysis of multiple stakeholders in e-waste recycling industry. E-waste is the fastest growing waste in the world, and recycling is an optimal way to manage the e-waste. However, 90% of the recycling is performed without any control, and this may lead to the serious consequences. In order to obtain the proper control in the recycling industry, it's important to consider the behavioral strategies of stakeholders. So in our study, we are going to consider the behavioral strategies associated with national government, local government, manufacturer, recycler, and consumer. We know that national government is the regulator of e-waste recycling industry, and he has two kind of strategies such as positive supervision and negative supervision. Under the positive supervision, national government is going to actively supervise the stakeholders' performance, and they are going to provide some subsidies to the stakeholders if they follow the proper behaviors, or otherwise they are going to penalize the discourage the behavior of the improper behaviors. When it comes to the both the national and local government, they are responsible for the environmental regulation. That's why it's important to consider the local government into account. So local government has two kind of strategies, such as the enforcement environmental regulation and circumventing environmental regulation. Under the next, we know that manufacturer is also responsible for the recycling process. He can have two kind of strategies, such as the co-design and non-co-design. Under the co-design, manufacturer is going to concern about the recyclability of products during the product design phase. Next, recycler is the executor of recycling, and he is going to perform qualified disassembly behavior or the unqualified disassembly behavior. Under the qualified disassembly behavior, recycler is going to follow the environmental laws by introducing new equipment and improving infrastructure. And then finally, recycler has two kind of strategies, such as green behavior and non-green behavior. Under the green behavior, consumer has the knowledge about the environmental green awareness, so that he is going to return her product only to the qualified disassembly recycler. And this is the game tree associated with our study. So first of all, we have to identify the payoff values correspond to all these 32 cases for each of the player based on their behavioral strategies. So in our payoff function include the economic, environmental, and the social benefits if they follow the proper behaviors. Next, we want to model how these behavioral strategies evolve over time. We are going to use the replicator dynamic for that. First of all, we have to define the state variables. For instance, X is correspond to the probability of national government choosing the positive supervision. And then the 1 minus X is correspond to the probability of national government choosing the negative supervision strategy. So here is the system of dynamical equation we obtain through the behavioral strategies of the players based on the payoff values. And then according to the industrial life cycle theory, there are 3 stages in the recycling process modeling. So in the first step, national government faces the pressure on social and environmental development, so that national government is going to follow the positive supervision behavior. However, due to the financial burden, other players are not going to follow the proper behaviors. Then in the middle stage, all parties play the leading position in the market, so that equilibrium point is the vector of ones. And then finally, in the major stage, without government involvement, all the other parties can achieve the main body of the market. Usually in the recycling industry, basically it's in the initial stage. so that the government intervention is needed to achieve this stability in these stages. So our research question is to determine the required level of national government involvement, that means the subsidy and penalty values, to achieve the stability in these stages. Then why is it important to consider the stability analysis? Because we can predict the long-term behavior of the system, and also we can improve the decision making. However, applying existing method to stability analysis in multiplayer evolutionary game is difficult, because when we add in more and more players, nonlinearity, dimensionality, and state space of the system increase, and also complexity further increases when the players have different roles from one another. So in our study, we are going to consider the optimal control theory for the stability analysis. The basic idea behind the considering optimal control theory is to find the control parameters which are required to achieve the stability in a desired equilibrium point. So here is the optimal control problem correspond to the initial stage. Due to this nonlinear high dimensional dynamics, this problem becomes non-convex. Reinforcement learning is promising to solve this sort of problem. That's why we are going to consider the reinforcement learning to solve this problem. In our problem, we have the continuous states and actions, so that the most suitable reinforcement learning algorithm is the deep deterministic policy gradient algorithm. So our contribution is to explore the suitability of deep deterministic policy gradient algorithm for the stability analysis of multiplayer evolutionary game model. And then this is the how DDPG works. It has 4 neural networks and 2 actor networks, namely actor and actor target networks. Similarly, critic and critic target networks. Actor networks learn the policy, which maps the states to action. We are adding some random noise to that because we want to do some exploration. And then to train all this network, we are making a sample from the experience replay buffer. That's the overall procedure. And then according to the simulation results, in the initial stage, we want to achieve that stability of that equilibrium so that we can achieve that. Then when it comes to the average episode reward, so we can see that in the initial episode, there is a bit of acceleration occur, then it converts to a value around minus 2.8. In here, I assume that the initial point of the evolutionary path has probability of 0.5 for each of the players. And then in the next stages also, we can achieve the stability. So in summary, our main target is to determine the optimal subsidy and penalty values. So here are the obtained results. According to the, here the financial burden means the difference between the total subsidy and total penalty. So the initial stage, it has the lowest financial burden, but when it comes to the major stage, we can see a higher financial burden. So that the national government decreases the enthusiasm of following the positive supervision strategy. We know that existing studies considers only the 2 or 3 players into the account, so that the results are suboptimal. But we have considered the multiplayers into the evolutionary game model so that we can obtain more practical conclusion. When transitioning from initial to middle stage, except the national government, all other parties can obtain higher profits. This motivates them to follow the strategies in the major stage. So ultimate goal of the national government is to achieve the sustainability benefit. So if the players follow the legal and environmentally friendly behaviors, then the national government can achieve the sustainability benefits. In the major stage, government prefer to follow the legal and environmentally friendly behaviors so that the national government achieve the sustainability benefits rather than restricted into the economic benefits. However, in our study, we haven't considered the uncertainty associated with the environment. So in future studies, we can account that as well. So thank you everyone for listening.